So I'm going to tell you a little bit more about quantum computing. I'm going to motivate the problem for you. I want to tell you why we're bothering, and I want to tell you why this is really just a completely different type of computing from anything you've seen before. So the computers we use today, your smartphone, your laptop, the servers on the internet, we're going to call these classical computers. They go back to the 1940s. And in the early 1980s, the physicists were asking, is this the best we can do? Right? Just because we invented these binary, these digital computers, is this what computing is going to look like forever? Will they solve every type of problem? That is. Because they were beginning to get some indications that maybe, in fact, that wasn't true. That computers can do a lot, and in fact, if you look at your smartphone, there are many, many apps you can choose from, well over 2 million, probably a lot more than that. But are there certain problems that are really just intractable for traditional classical computers? These are the two fundamental principles of quantum mechanics that also come into play in quantum computing. The first is called superposition. This is sometimes incorrectly said, a qubit is 0 and 1 at the same time. Mathematically, it's a little bit more complicated than that. But it's still a strange idea and gives rise to some other interesting and powerful behavior. And the second is what's called entanglement. Entanglement means that if you have one particle here and a second particle, possibly millions of light years away, if you know something about this one, you know something about the other. Quantum computers are fundamentally different from the very lowest level all the way up. They will not replace classical computers, probably for a few hundred years, but they will work together with them. They will complement each other. Quantum computers, we hope, will be used to solve the problems that, as I've described, classical computers cannot. We'll be able to simulate chemical molecules and not just little ones like caffeine. We may be able to create new life-saving drugs. We will go from drug discovery to drug computation, specifically for you. This is a very exciting time in computation. I hope you join us. Thank you.